So welcome. What I'm going to show you today is how to create a line graph with standard error bars. Note that this is for students with continuous data. If you have qualitative or discrete data, you will complete the next module that shows you how to do error bars with a bar graph. Please note that with the exemplar, they didn't stop at one graph and did an interpretation analysis. They did multiple, and hence we want you to do the same. So with the line graph, you'll notice it's a good way of representing continuous data. And why are we going to include error bars, which probably a lot of you haven't done before? Error bars are really great at communicating these three things here. I just want to note that this text was taken from a website, and you'll notice that they discuss standard deviation error bars. We want you to use standard error bars. So the text is still the same, the way that you would word it is still the same. However, this is the only thing that will change, this accuracy instead of reliability. So why do we want to include these error bars? Because they can communicate to us how spread out the data is. If the error bars are small, we have a low spread, and if they're large, we have a larger spread. The error bars can also talk about the accuracy of the mean value. They can communicate that to us. If we have a small standard error bar, it means that our mean is more accurate. If it's larger, it means our mean is less accurate. Notice I replace the words reliable with accurate. And it's important to note that if you have a larger standard error, it does not indicate that your data is not valid because biological measurements are notoriously variable. Standard error bars can also communicate to us the likelihood of there being a significant difference between data sets, and this is really important, and that's why we expand on that here. So what does significant difference mean? It means that the results that are seen are most likely not due to chance or sampling error. So the standard deviation error bars on a graph can be used to get a sense of whether or not whether our results are significant. Notice that these error bars are drawn on a bar graph. That's fine. It doesn't make a difference if it's drawn on a line graph. Notice that here the error bars overlap with each other. If you have that happening, what you can say is that the difference is not statistically significant. You can use that language in your interpretation/analysis. Notice here it also says you must perform a statistical set test to draw a conclusion. This statistical test will be your final data analysis, and that will be in a later module. Notice if there's less overlap, you can say the difference is probably not statistically significant. And notice if there is no overlap whatsoever between the error bars, the difference you can say between the variables between whatever you're comparing here, may be statistically significant. Again, you have to perform a statistical test to draw that conclusion, and I'll show you how to do that later on. So creating a line graph in Excel, again, just like the previous module, you have to slightly change, you have to create a new table for Excel to easily create our graph. On the left-hand side of our table, again, is going to be our independent variable. So here it's sucrose concentration. Notice I put the unit in brackets. That is important. And we pop in our independent variable concentrations. I missed a number. Notice I don't have any symbols after my numbers. In here, you want your dependent variable, but this time you're going to graph your mean value. So mine would be mean change in mass, and it's the percentage change in mass. So percentage is my unit. And like I said, we're going to graph standard error bars instead of standard deviation bars. So we need to also include our standard error over here. So we have easy access. Alright, our mean change in mass numbers, that will be those here. Now if I copy and paste them, you'll notice that it does not do that easily. So I'm just going to fix them up. And then you want your standard error as well. Just make sure you always paste your values. There we go. So again, this table won't get included into your report. It's just necessary so we can create the graph. So when you create your graph, notice we are creating a line graph, but we're not going to select line graph up here. I'll show you what we'll do. So highlight your data, only highlight your independent variable and your mean values. Don't highlight the standard error yet. Highlight your data, go insert. We're going to click on scatter, but this time select the option with the line, so scatter with smooth lines. And again, we're going to delete that title because as shown in the previous module, the titles on the exemplar show that they have to go underneath our graph. Again, it's very important that we include our axes titles. Didn't mean to do that. So we're going to click on the plus sign, axes titles. If you don't have the plus sign, again, go up to design and add chart element. My independent variable is the sucrose concentration. In brackets is my unit, which is percentage. And my dependent this time will be mean change in mass. So make sure you pop in that mean there. Cool. Alrighty, so what we need to do now is include those error bars. So you need to go to plus or up to add chart element, and you can see error bars is an option. Please don't just click on the tick sign because it's going to be incorrect. You need to go over to the arrow and click more options. And in the more options, you'll notice that it for some reason goes to fill in line. I want to go over to the chart option. And I need you to go to the bottom. You'll notice it says fixed value 1. We don't want to fix the value. We want to include our standard error values. Again, if you click standard error here, it will be incorrect. You need to hit custom and go specify value. The positive error values, if we look at the example here, the positive error values is just saying from the blue line here, which is the mean, and up, that's the positive, and below is the negative. For when we create our graph, these numbers are actually the same, so we can open the positive error values and highlight our standard errors, close it, and then the negative error values, we open that and we actually select the same standard errors, and then we close that. We then can hit OK. Now on the line graph, you'll actually notice it does error bars both. I just zoomed in because I found it easier to do this last time. You'll notice it does above and below, but also side by side. We don't want the side by side values, so you need to muck around because it took me a while last time. And you need to see how I clicked on it, and that's showing the side by side. Once I've clicked on it, I can hit delete. I'll zoom out again now. And you can see only the error bars that are above and below are on my chart. That's what you want. You can now copy that into your report. Sometimes it might be easier to print to see if these bars overlap, so you can start making your interpretation and analysis. I hope that helps.